Hello, gang. All right, we're going to discuss Chapter 10. And Chapter 10 is on DHCP. And remember, DHCP is Dynamic Host Configuration Protocol. This is how you get IP addresses out to your clients. And it's important to know that routers and switches are capable of doing this, even though in lots of cases they're not used for this purpose. It is added in there. It's something you can turn on them. In general, in most of the networks that I've been involved in and that I've seen set up, you're going to use a server to do DHCP instead of the routers and switches themselves. So, for example, if you're running a big Windows domain, active domain, you'll have one of your Active Directory servers, or maybe two or more of them, doling out DHCP addresses instead of it being done by a router or a switch. But if you have a very small network and you don't have routers, you don't have servers of any kind, it's added in there. You can have your switch do it for you. So we'll talk about the two types, DHCP 4 and 6. We'll describe DHCP 4 in a small to a medium business network. We'll talk about how to configure the router as a server and as a client. We'll talk about how to troubleshoot. We'll talk about 6 under the same ways and how to troubleshoot 6. So there are 3 different allocation methods for DHCP on V4. And we call it V4 and V6 just to make it easier to remember the differences in IP4 and 6. But I'm going to tell you I'm just going to use DHCP as we're talking about that. And I will say specifically 6 if I'm talking about DHCP 6. So in manual allocation, the administrator assigns pre-allocated IP4 addresses to the client, and the server communicates only via the IP4 address to the device. In an automatic, it's assigned a static and its address is permanently to that device, selecting it from a pool of available addresses. And then in dynamic, your IP4 is leased from a pool, and that machine has that address for a limited period of time chosen by the server, or until the client no longer needs it, so the client releases it. This is what's commonly used. Almost everything that I've ever done has been dynamic allocation because it's fairly easy to set up and it's easy to maintain. So here is basically how that works. You have a machine that sends a DHCP Discover broadcast address, which essentially is a packet saying I need an IP address. Then the server sends a unicast packet back that says I'm the server, I have an address I can offer. Then your client says I will take that address offer, thank you. And then the DHCP server sends back a unicast saying your acceptance is acknowledged. Once that's done, the IP address is assigned. Then the server is going to take that out of the pool so that it knows that address is marked. It won't try to give it to some other machine. Here is what a DHCP4 message looks like. This is how it is, how the frame is built. You've got hardware type, hardware address, hops, a transaction identifier. Then we'll skip down. You see we've got a client IP, your IP, the server IP, the gateway. And then at the end, those DHCP options are important because there's lots of other things I can specify if I want to. Something, for example, that I almost always specify in all DHCP servers I set up is an NTP server so that they know where to go to get their time synchronized. Here we're just seeing a DHCP4 Discover message. Client A wants an IP, the server's there, the server has it. The Ethernet frame goes out, it goes to destination all F, so it's a broadcast. Since it doesn't know the IP address of the server, it has to broadcast it in order for it to see it. Remember, the general rule is that switches pass on broadcast frames, but they don't pass on unicast frames unless they specifically are told to send them to a port. So this would go out all the ports that are on the same switch. Now remember though, I said it's a broadcast, so unless something specifically is done, and I think we'll be looking at that shortly, it's not going to go through VLANs and it's not going to go through subnets. So a Cisco router running Cisco iOS software can be configured to act as a DHCP4 server. To do that, we first set it up, we have to exclude addresses from the pool, set up the pool name, and define the range and subnet mask. Use the default router command for the default gateway. Optional perimeters can be included, like DNS server and domain name. Turning it off, no service DHCP. So here they're turning it on, they're setting up addresses. So to see that you're getting an address from a server, on the server itself, you can do show run to see what you see. But on the PC, the command ipconfig/all will give you information. And if I run that, I'll do it both ways. If I just run it, you're going to see on my machine you get a lot. But you can issue the pipe more. Now the pipe is the big colon, and the way you get that, it's the shift and the backslash. And now I'm going to stop line by line. So we see here that I've got no connection right now on the wired. But if I keep going down, I see my wireless. Here's my wireless, and I'm assigned IP address 192.168.1.142. It was assigned to me June the 29th, and it's going to expire July the 1st. And it was assigned by IP 192.168.1.1. So, and all of these others you see on here are different interfaces I have, and because I'm running virtual software, VirtualBox. VirtualBox has its own interfaces, so it gives them IP addresses. And I'm also running a what's called a Teredo interface for IP6, so that gets an extra address. But that's a good command to use to see what's going on. So using an IP helper address enables a router to forward DHCP4 broadcasts to a DHCP4 server. Basically, that turns it into a relay. This command will allow that to a DHCP4 request to leave a network and reach another network that has a DHCP server. It is not uncommon for large organizations to have one big DHCP server that gives out addresses for like an entire campus. And the beauty of DHCP4 is that it's standard. So here they see this helper address. That may point to a server, not necessarily to another Cisco router. That could point to a Windows or a Linux server, and they could be given an IP address just as easily. You may also want to configure it as a DHCP client. And in that case, it will get its IP address from another DHCP server. And here are the commands to do that. So there are some tasks that you may need to do in troubleshooting a DHCP server. One of those is resolving conflicts. That becomes a big deal when you change DHCP servers because one may not have a list of what the other one has. You can also verify your physical connectivity, verify the switch port configuration, and test from the same subnet or VLAN. So here they're showing to verify it. We can do a show running config, and in this case they're piping it and only showing interface gigabit Ethernet 00. So here I see that I have a helper address on this network. So IP helper address is 192.168.11.6. A DHCP request on my 10 network is going to go to 11.6 to get its IP. Here they're showing how to use the router debug commands to actually look at the packets. And we're debugging IP packet 100 in this case. So IP source 0 destination 255, that's going to tell us that that is a broadcast and the length of it, so we can actually look at the package. If we do a debug IP DHCP server event, this shows what commands are sent to the server and what IP addresses it has given to people. Notice it says IP address assigned to client, and then it's going to give the MAC address that it's assigning that client IP to. So V6 is not that different, other than it's just built a little different. IP6 uses what's called stateless address auto configuration, and it's a message to obtain an IP6 global unicast address without the services of a DHCP6 server. Right now, this is what most places are using. A variation of this is what I use at home on Comcast to get IP6 addresses on my system. And different routers call it different things. My PFSense router at home that runs FreeBSD calls it a track interface, but here they call it SLAAC, or SLAAC. And the way this works is with router solicitation. I need a router advertisement packet from the router. Then we get the advertisement. Then we're going to create an IP6 global unicast address. After I get my own interface ID, I can use the prefix to create my own IP6 address. Once I've done that, then I can make sure no one else has it. If no one else has it, then I can use that for an actual IP6 address. So here notice that SLAAC is the default, by the way, for IP DHCP6. And that's done with router solicitations and router advertisements. So here we send a solicitation. We're going to get back an advertisement. The RA has some of the addressing information I need, but I need to contact a DHCP6 server for other information, such as a DNS server. So these can run together, and that's important to know. So here it tells me that in this case, for stateful, I need all of my information from a server. So I'm going to go back to the server to get that. So here are the commands to configure a router as a stateless DHCP6 server. So my first command is going to be IP6 unicast routing. Under that, I'm going to assign my DHCP pool. So I will do DHCP pool IPv6 stateless. Notice that it's in all caps, IPv6 and stateless. It has to be in all caps because these commands are case sensitive. Below that, I'll do a DNS server, and I'll put the address of the actual DNS server. So in this case, we're going to use the address 2001 DB8 CAFE, then quadruple A : 5. We're going to give it a name. In this case, we're just going to use example.com, and we'll exit. We'll go to interface gigabit 01, and we'll issue the command IP address give it 1, a /64 subnet, which these are common. We'll turn the server on with IP6 stateless, and then we'll issue an other config flag to put the rest of our commands in. Finally, we've got to turn it on, so IPv6 enable and then address autoconfig. To verify it, we can do show IPv6 interface, and we can debug IPv6 DHCP detail to show the details. Now stateful, on the other hand, is some more commands. I've got to tell it how long. In this case, lifetime infinite. If we can continue on down to verify, we can do show IPv6 DHCP pool and binding, and that will show that IP6 is actually on. Here we've got it set up also as a relay agent. We can set IP6 up to relay out to get us actual IP addresses. Much like with 4, things that can occur with IP6 are conflicts. Again, that happens a lot when you have one server that you take down and bring on to another one. And in the Windows classes, we talk about ways to get around that with something that's called an 80/20 server. And I don't know the commands on Cisco, but I'm pretty sure there's a way to do it. You can also have the IP address pinged with an ICMP request before the IP address is assigned. That way you know if it's actually in use or not. And that's something that's good to turn on when you're moving DHCP servers, because it'll actually take longer time, but it'll ping that address before it tries to assign it to anything. Here we're verifying it. IP6 unicast routing. We can do DHCP pool, stateful. There's our address. Lifetime infinite. Then we're going to put the managed config flag. Here, if we do a debug, it'll show us that it received a solicit from here. It assigned an address using the pool that we set, IPv6 stateful. And that is pretty much DHCP in a nutshell. 4 has 3 types: manual, automatic, and dynamic. Generally, you're going to use dynamic. There are 2 methods with 6, stateless and DHCP stateful. Stateless is what most of us are using, and that's those track interfaces I talked about. And the reason that even occurs, just to kind of give you a real quick rundown on 6, when you get assigned an IP6 address by an ISP, you're generally, because there's so many of them, you're assigned an entire class 64 subnet. So you take that class 64 subnet, and then your computers or your clients are actually going to determine their own IP addresses based off a combination of the 64 subnet and the MAC address of their own machines. And generally there's no conflicts there because A, there's so many IP6 addresses, it'd be crazy for a conflict. But B, because it's unique based off of the information from the DHCP server and the MAC address of the client. So that makes it where they're a little bit different. So 4 and 6 both have to have conflict resolution. You can verify the switch port, and you can test them on VLANs. And that is a rundown of DHCP on Cisco.